All right, so let's talk about event handling. So we want to be able to handle a stream of events, right, as the user interacts with an application, right? As the user clicks and drags and types at the keyboard, right, they generate a stream of events that we need to be able to capture, right? And presumably those events are meant to enact some change in the application. You're either deleting something, right, or you're going to update something, right? You're going to insert something. You are interacting and telling the application that you want to modify its state, right? Even just moving the mouse, as you're hovering over a button or hovering over some. Presumably, we might want to maybe give some feedback to the user and change the background color, right, or some hovering color, right, to just give the user some feedback that, hey, we're listening to you, right? Any changes that we are aware of your actions. Uh, so so here's a trivial example of an application that can handle a click. Okay, now up to this point, all the components that we've been implementing, pages and any components, anything that ends with TSX, right? These have been components that have been rendered on the server. Right? The server is running these functions, right, and creating the HTML and the DOM, all that then gets streamed over to the client, to the browser, and the browser just adds all the DOM that's coming from the server already rendered, right, and adds it dynamically into the browser's DOM. Okay, and that's fine. We can do most everything just with what are called server components that are rendered on the server. Right, this is a Next.js feature, right, that it can optimize the performance of rendering content by running it on the server and doing a lot of caching, a lot of optimization on the server side. But there's some things that cannot be rendered on the server, right? Such as things that we interact with a form. If we're filling out a form, we're clicking something and something needs to pop up on the screen. Those things cannot be executed on the server. Those kinds of things need to be executed on the client, right? The browser is the one who's going to handle the event, right, and is going to dynamically modify the DOM, right, or pop up an alert or something like that. Okay, and so these types of components, we have to tell Next.js that explicitly. We have to tell it that, hey, this component is not supposed to render on the server. It needs to be rendered on the client, right, because it's interacting directly with the user, right? So to do this, you will have seen in the book that I use this string at the top. It says use client, right? This tells the rendering engine, the Next.js framework, right, that hey, don't render this on the server, right? Let it go directly to the client. The client will run this JavaScript, okay, right, and will handle it from there. Okay, if you don't add the use client, the server will by default assume that this is a server component. Okay, although if you put things such as on click, right, the server will complain. It says, no, I can't render this on the server. This must be a client component, right? So it'll complain, and so you'll know, oh, I forgot to add use client, right? So yeah, so if you see use client here, we are explicitly telling the Next.js framework to not render this on the server by default. Instead, let it go through to the browser. The browser will compile this on the client side. Make sense? Right. So yeah, so a lot of the components that you'll see today, pages and components and whatnot, if it deals with user interaction, like clicking and typing something on the screen, then that you'll need a use client at the top. Okay. All right. So what do we have here? So we have here the simplest of components that can deal with user inputs. Okay. And the simplest of inputs is just us clicking on something on the screen, right? And we can handle clicks by using the attribute onClick. Right? We can add the onClick attribute on any element, and then it becomes clickable, right? Now here I'm applying it to a button, and that makes sense, right? We want to click on a button, but really onClick attribute can be applied to anything. We can apply it to a heading or div or paragraph, anything that we want to capture the fact that the user is clicking on this. All right, but most commonly we apply it to a button because it looks clickable. Okay, Now the syntax is slightly different. We introduced onClick a little earlier when we were looking at JavaScript very briefly last lecture. Okay, and the syntax was slightly different if you remember. In that syntax, this was all lowercase, and instead of curly brackets, it was using double quotes. Remember that, right? Here, these are not these are embedded functions, right, or references to functions. So we use the curly brackets, right, as a pointing out that this is an expression, right? This is a reference to some executable function, right? And we are providing either a reference to the function, or we are embedding it, right? And the function inside of the event handler right here. Okay. Now let's talk about the difference between these two syntax, right? Notice that this syntax over here, it has the name of the function that is declared up here. Right? It says hello, and I'm just providing here the name of hello. Careful, because in the last lecture, when we looked at plain JavaScript, raw JavaScript implemented in raw HTML, if you remember, the syntax there was slightly different, right? It was the name of the function and then the opening and closing parentheses. Remember that, right? And here we're not putting the opening and closing parentheses. Okay, actually, careful. If you do that and you put the opening and closing parentheses here, you might end up in an infinite loop. Okay, the function here is different, is interpreted differently than it's interpreted in the raw JavaScript. Okay, in raw JavaScript, the when you put the function there with the parentheses, that's not going to run immediately, right? Instead, it's postponed until you actually click on whatever it is you're clicking on. Okay, and then it calls the function. Whereas over here, if I had the opening and closing parentheses, right, it would call the function immediately. Okay, and that would cause a state change in the component, which React would interpret as, "Ooh, I need to re-render this component." It will re-render the component. It will call the function again, right, and which causes a state change, which will re-render the component. So it might end up in an infinite loop. So careful, right? So yeah, no opening and closing parentheses here. Instead, it's just a reference, the name of the function right there. Okay. Okay. And yeah, this function will only run when you actually click on the button. It's postponed. Now, what happens if you want to pass arguments to the function, like this one? Here's another function that takes an argument. How do you pass parameters to the function? Right. Well, here it is. Here's a function, and us calling the function with a parameter. See that? Right. But to postpone the function to be invoked later when the button gets actually clicked, we need to wrap it in another function, right? This outer function. Okay, notice that it's an anonymous function, has no name. It's a lambda function. Okay, and so this is what's called in JavaScript a closure. Okay, and we'll talk about closure in a little bit. There's a really cool features. One of the features is that it postpones the invocation for later. Okay, what it does actually, it copies the state of the component right now, all the variables, any constants, right? It copies it so that it remembers, right, later on when the function actually gets invoked, you can reinstantiate the state. But we'll more on that a little later. Okay, but this closure basically what it does, the feature is that it's postponing the invocation for a later time, right? When the event actually happens. Okay. Now notice that this syntax is that it's a one-liner, right? So we are not using a return. Notice that we're not using the curly brackets. So this is using the implied return syntax. See that? So whatever this function returns is this whole thing is returning whatever that function returns. Okay, which in this case is not returning anything. It's a void. Now, if your event handler is more than a couple, if it's just a couple of lines, you could alternatively put a body, a function body with opening and closing parentheses, curly brackets, and then just a couple of lines of executable code in here. No more than that. If the function is complex enough that it requires loops and if statements and whatnot, it's better. It's best practice not to make these complex, right? Very complex. Instead, if it's something more than 2-3 lines long, you just declare a separate function, right? And then call it from here. All right. Okay. But I mean, you can put here and embed a function. It's pretty common. So yeah, so when you when you click on hello world, it invokes the function, and then it alerts, it pops up an alert. This one is calling the life is good, and it's passing a parameter, and this one is just calling hello first, and then life is great. Okay. This is just as a reminder, right? That if you do need to pass an argument, right, to a function like this one, add takes arguments a and b. Okay. Be careful not to do this, right? To just say add and then the arguments. That might get you into an infinite loop. Always remember to wrap it inside of a closure. Okay, everybody good? All right. You can also pass functions as arguments. We're very familiar to passing any parameter, right, into a function. Certainly, all are primitive data types, right? Booleans and numbers and arrays or objects, but also you can pass functions around. Okay, you can pass it as an argument, and this is very, very common in JavaScript, right? Usually, it's a way of sharing behaviors between multiple components, right? That are it's too complex to have it all in one component, right? And typically, you break it up into multiple children components, but then you have to share data, you have to share behavior, share functions. It's very common to pass as a parameter, pass a function, right? And then from within that child component, assign it to an event handler. Right? And that event handler, when you click on it, it calls a function that was passed by its parent right to it. See that? Right. Now, when you receive a function as an argument, you do need to declare it. Just like you declare any attribute, right, that you pass, or any argument that you receive, right? Those might be data types, might be number, string, Boolean. Here, we're saying that, hey, you're passing us something that is a function, and this is the signature of a function that takes no arguments and returns nothing, right? Returns void. Okay, so we're just saying that, hey, we're expecting a function here. When we click on it, here's us passing it. There it is. We're passing it to this component, passing functions, right? And we're passing it as an attribute, and then a reference to it, some function that we are passing a reference to it, and then we can use it here to call it, and then it invokes that function. It's very, very common, right? That two components pass data and functions, to each other, right? So that they can talk to one another. Make sense? Okay. All right. So let's talk about local state. Right. So again, what we mean by state is a snapshot of all the variables, right? All the data structures that are maintained in memory of the application, right? At a particular time, right? At a particular snapshot. Yes. And up to this point, that data that we've been using so far has not changed. It doesn't change over time. Yes. We can't manipulate it. Not yet anyway, right? But now we're going to start considering the fact that we should be able to manipulate this data, right? I should be able to add new courses, remove modules, update my assignments, right? So the state is going to change over time. And as the state changes, we need to be able to re-render, right? Run the React engine, right? To recalculate, right? What the new user interface looks like, right? To give the user feedback, right? That their actions are actually doing something, correct? Right? Now, what the state can be something as simple as a checkbox, right? Or maybe a couple of input fields, in the sign up or the sign in or our profile screen where we're filling out our username, password, first name, last name, date of birth, right? We're filling out a form, and that information might be only relevant to that one screen, and that's it. Okay. Now it might be also that perhaps that page might be using several child components, and it might need to share the data and behavior with some child components. Yes, that's still fairly localized, right? It's fairly relevant only to just a couple of a page and a couple of components. We still call that a local state. Now, if that state is instead much more complex and might be relevant not to just one page, but perhaps across multiple pages. Yes, right? That a lot of pages need to collaborate with one another with some shared data that is relevant across an entire application. That's no longer local. Okay, we call that maybe like global state or maybe application state that is relevant for the whole entire application. Yes, right? And the strategies to deal with these two types of state is significantly different. Right? So we'll first take a look at the simple case of looking at local state, right? And then we'll talk about global state. And going back to the exam next week, the exam does cover local state. So some of the material that we're going to talk about today here, that's going to be in the exam, but global state is not going to be in the exam. Right? For that, we'll need maybe an assignment or two to be able to practice that. Right? It is significantly more complex to deal with global state. Right? But local state is fairly trivial. Right? So let's talk about local state. Okay, so let's talk about local state. So here's a trivial example where we have a variable that is maintaining a count, right? And we want to be able to see if we can change that count over time, right? And up to this point, we haven't looked at this problem of changing something, changing some variable or an array or an object or anything like that, okay? And we just learned how to be able to handle user input, such as clicking. So for instance, our click, on a button that's up button, we might have something such as, take the variable, notice it's let, right? It's not const, it's let, so presumably we can change it. And so we can try to change it by saying count plus plus. And as we would expect, right, that 7 would become 8. If we click it again, it would become 9, and so on. And notice that we've added a console to display in the console the value of count. And same thing, we have here a down, which is going to decrement the value, right? Presumably it's going to go 7, 6, 5, 4, and so on. Okay, and now, and indeed, if we run this in a React component, what we'll see is that if we look at the console, indeed the variable is changing over time, right? If we click on up, it goes 8, 9, 10, 11, so on, right? If we click down, it goes 11, 10, 9, 8, and so on. All right, so it is changing, right? The variable is changing, but notice that here we are rendering the count, we are rendering it on the screen, but it's not changing. Right? The value, what's rendered, the 7, is not changing, even though the variable is changing. See that? Right? And that's very common. That's exactly the way React was designed. Right? React was designed to be lazy. Right? Lazy when it's modifying the DOM. Right? It is trying to optimize, right, the access to the DOM. Right? So writing to the DOM is very, very time consuming. Okay, it's a very big data structure, right? And the time it takes for a program to go out to the DOM and find the node and actually manipulate the data in the node is fairly complex and time consuming. So to optimize this, React maintains a data structure of its own, right? A virtual DOM, right? A DOM that is far more compact, right? Far more optimized, that it's very, very quick to modify the DOM, the virtual DOM, okay? And it tries to accumulate all these changes to the virtual DOM so that once it has accumulated all these changes, it can then go ahead and dump all those changes on the real DOM all at once, right? As opposed to doing small little updates to the DOM, right? It makes a wholesale modification to the DOM all at once. Very much like what we find in databases, right? In databases, typically, right, the application, the database application maintains a cache, right, of the data that is in the file system. Yes, because writing to the file system is very expensive. It's very slow. Okay, so it maintains a copy of it, right, and all the changes are happening to the cache, and in turn, in certain intervals, it makes a wholesale writing to the database, right, all at once, as opposed to making small little updates to the database. It does all bulk updates to the database because it's far more efficient. Make sense? Yeah. So same kind of deal here, right? Writing to the DOM is expensive. We have a virtual version of that, and React is trying to optimize the writing to the DOM. So now, yeah, in this case, we see a side effect of that optimization. As far as React is concerned, the DOM is up to date, right? There's no need for me to go back to updating the DOM, okay? Yes, this variable changed, but hey, there could be tons of variables in here, okay? And there could be dozens of variables, each one changing here and there. It's not gonna, keep track of, well, what needs to be rendered or not rendered, yes? Okay, it's it's very much like a rendering engine in a game engine, right? Where you might have all sorts of things happening on the screen, and then in your rendering loop you might have the position of characters, positions of missiles and players and vehicles, yes, and at every time you're computing the position of all these things, all right? And as you're iterating through your calculation of where everything is, at the end of the cycle you say, okay, well, I'm going to, oops, did I lose that? At the end of a cycle, then typically the algorithm says, okay, I'm done with all the calculations. Please, rendering engine, go ahead and re-update the screen. Okay, so same thing here. We need a mechanism by which we do all the computation, and once we're ready to do all the updates, right, we want to ask the rendering engine to go ahead and update the user interface. Make sense? Right? So instead of every time something changes, instead of every time there's a little change in one variable, we don't want that to cause to immediately update the screen, right? We want to have control over when we change the state and when we tell the rendering engine to go ahead. It's worth going out and updating the DOM. Make sense? Right. So to do that, we can tag specifically which variables we want to be tracked, right? And which ones we want to, that are worthy of being updated on the screen. Because we might have 10 variables, of which maybe one or two we want to display on the screen. The other ones are just there for intermediate computations or whatever, right? For internal algorithmic purposes that we don't want to render on the screen. So those that we do want to render on the screen, we're going to name them state variables, variables that have a state, right? And if the values of these variables change over time, we do want to render them, okay? And the way we do that is by declaring them using a hook called useState. Okay, useState allows us to declare a variable, initialize it, give it an initial value. So very much like before, here we're declaring the variable, we're giving initial value. So here same thing, we have a count, right? And we are declaring its initial value, okay? And we can use this variable like we would use the original variable. It's still rendering as 7 as before, okay? But the syntax is slightly different. The syntax is that useState returns two things. Well, it returns one array with two things in the array, okay? It returns first the value of the current state variable, okay, which you can assign to a local constant. That's what we're doing here. Notice that the square brackets on the left side, what does that do? It's a destructor, yes? Right. That means that useState is returning one array with two items. The first item is the current value of the state variable, right? Which as its initial value, it's 7. So my constant here that I'm declaring here gets the value 7, yes? And I can treat it like I was treating my original variable, just like before. It doesn't change. So count, I can use it everywhere else. I can display it here, just like I would any other variable. Make sense? Now, the second item in the array is a function, right? And we're destructing it, and we are assigning it to a local variable here, or constant, and I'm calling it setCount. Right? And that function is going to allow us to first modify, right, or calculate the new state of the variable, and also request a re-rendering of the DOM, right? Now, notice I said requesting a re-render. It doesn't actually immediately render the DOM. Right? It just tells the rendering engine, hey, at your earliest convenience, okay, whenever you're done, right, accumulating all the changes to the state, all right, whenever you can, whenever you have some cycles, please update the screen at your earliest convenience. Make sense? Right. So set count, this function we refer to as either a setter function or a mutator function. It's a function that allows you to mutate, right, the value of the state variable, right? And we would use it as such. For instance, if we do a plus or up, we would say, change the count to be whatever the count was plus 1, right? And this one would change the count to be count minus 1. Yes? Right? And we would not instead make direct changes to the constant. We can't. It's a constant. We can't change the constant. Right? That's the whole point. It would not let us change the constant. Instead, right, we would do it through the mutator. We tell it, hey, the new value is so and so and so. And it's often the case that the new value is some variations of the previous value, right? In this case, it's whatever the previous value was plus 1, or the previous value minus 1. Make sense? Yes. We don't have what? I'm sorry. Where, here? Yeah, no. So this is being assigned. So this is a constant, and set count gets the value that's being assigned to set count. Set count is the value of a function. Like we did earlier here. Set count is a function. Yeah, just like here. Right here, we're declaring a constant, and we are assigning it a function. Right. So it is a constant. So the same thing here. Right. This is a constant, is it's receiving a reference to a function that has been declared and created by useState, right? By whatever magic useState is doing internally in there. Okay. Now notice that we are using a square bracket notation. That means that these names here, these names could be whatever I want. Okay. I mean, I chose count because, right, we were talking about a counter, right? And I was using a name of a variable that made sense, count here, yes? And so I chose count. Same thing for the name of the function. I chose set count because it makes sense, right? We are changing it, we're mutating it, and this is the proper, the proper naming convention, right? If this is count, then this would be set count. If this would be first name, this would be set first name. And that is a proper naming convention, yes? Right. But nothing is stopping me from calling this X and calling this Y. It's whatever name I choose, okay? These names are not in any way maintained by useState. useState is just returning to us a value for, in the first argument, in the first element of the array, right, some value. And the second one is a reference to a function that you can assign it to whatever you want. Okay, right? So don't be disconcerted if in my quizzes or my exams I use here A, and for this one would be B. Okay, then this would read B A plus 1, and it would totally work. Okay, actually expect all my quiz questions being like that, because that forces you to read the code and see what's happening. Right? If I use an actual name, you immediately know what this is doing. Right? But if the names don't make sense, you actually have to read the code and try to understand what's happening, what the algorithm is actually doing. Yes? Right? So yeah, so these names are totally arbitrary. Everybody good? All right. Yes. No, it's not changing. So what happens is that when we call set count, right, we're telling the useState to change and compute a new value for count, right? And this will return a new array, right? And this will be assigned a new value. Whatever new value you told us to set, that will be the new value that this will get. And the whole thing re-renders, right? The whole component re-renders with where count now would be some new value, but it's still a constant, meaning you could not do count plus plus, right? Or count minus minus minus, right? Because it's declared as a constant. It re-renders the, right, it re-renders. Now you see the changes. Now, if you click on plus, right, the value changes 8, 9, 10, 11, and it re-renders the component. Yep, recalculates. Then the constant will be called set count, and the function would be called count. Because remember, in arrays, it's the position that matters, not the names, right? Whereas if this were curly brackets, right, the name matters, but the position doesn't matter, right? So, but in square brackets, the position matters. Yeah. Yes. Yeah. Yeah. It's a function. I'm sorry. Yeah. No, but we don't implement set count, right? It's provided to us by useState. So useState returns an array, right? And the first item of that array is the current value of the state variable that is maintained by useState. We're not maintaining it. useState is maintaining it. And the second element in that array is a reference to a function that we can use to modify the value of the state variable. Okay, and also it's a request to the rendering engine to, at its earliest convenience, because you can have a lot of state variables, right? And you're changing my first name, the last name, my email, blah blah blah. All, things are happening, right? And not until all the it's not synchronous. The change is not immediate, right? It can accumulate all the changes, right? And once it has all the changes, it wholesale changes all of them at once, right? So, for instance, even though I set count, I can't assume that right after the set count, the count is now plus one. For instance, I can't, right? For instance, if I had this set count in my second line, count would still be my old count, right? Yeah. So set count, and this will not immediately change the value of count. It'll only so if I have a second or third line here, count has not changed yet. So you have to be careful, right? So you cannot write the code like it's synchronous, as in the change has changed, right? You can only assume that in the next rendering, right? In the next rendering, count will change when it re-renders, and then you get a new value of count. I'm sorry. Uh, if you have lines right after it, it'll complete all the lines before when it comes back after that function. So if this is inside of a function, right, and the function has several lines, right, it will complete the function, right, and when the function completes, then the change will happen. Yeah. So you have to be careful, because in that line, in those lines, you can't assume that count has changed yet, right? So what you typically do is perhaps change the value of count, right, locally, and then in the end, you call set count with whatever new value it is, right? If you need it prior to calling it. Yes. Yes. Yeah. It's the most efficient way. Yeah. Well, it's actually the only way to change state. Yes. Yeah. For performance reasons. Yes. For performance reasons. Yes. For optimization. So it only updates. So the logic up here does rerun, right? This function entirely runs, but then here it keeps track of who is actually the element who's needs to be updated. So it doesn't re-update everything, right? Only what's updated. Yes, that the last one wins. Yep. Say again. The last one wins. Yes. Yep. Yes. That yeah, we have a reference to it. Yeah. Yes. Yep. Yes. Yep. Say it again. Yeah, yeah, correct. Yes, but that's not. But that's not because the. It's not because it's a constant though, right? Because you could make a function. You can assign, just like any object, you can assign attributes or properties, right? Also to a function, right? So just like you have a let an object and then you have properties, you can later add properties and change properties if it's let. If you declare that object to be constant, you cannot change it. Same thing here. A constant function, you cannot change any attributes. Like for instance, if you're trying to keep track of how many times the function gets called, right? Or you want to keep track of some performance about that function, and so you would have to declare as a variable as opposed to const. Your const would not allow you to uh, change its attributes or keep track of anything on that function. But you can, if it's let, if this were let, then the function could be added, your own attributes or properties that you can keep track of, which is pretty cool and sort of dangerous. But yeah, you can. Yep. Uh, Okay, so I'm going to go through several trivial examples of state variables, right? So that we get a chance to practice this, and with simple data types first, right? Then we'll get to some more interesting data types or structures, arrays, objects, and whatnot, right? So here's example of a Boolean state variable, right? Where done here gets the value of a Boolean value, like true, okay? And so it's initialized to be true, and then set done allows it to modify it so that presumably we want to change it from true to false or false to true. Right? And the way we're doing that is through this input field that we're declaring as a checkbox, right? And notice that instead of on click, we are using on change, okay? And so this is a slightly different than over here. We're using on click. Here we're using on change. So there's some input fields that only have that deal with data that has a range of values, right? And other input fields that deal with something that has no range of values, right? So in this one, we're you're just clicking it, right? Whereas over here, right, the thing that is changing could be changing from true to false or false to true, or as we'll see a little later, as you're typing, right, the strings change with each character, right? So this on change allows you to capture, right, the states change, right, either of characters changing over time or string, right, or a Boolean changing from true to false or false to true, right? So there are dozens and dozens of these event handlers. We're only going to look at only a handful, like on click, on change, double click, things like that. But on key press, and things like that. But there's dozens of these event handlers. Whether you're hovering or you're exiting, there's tons of mouse over, mouse out. I mean, there's tons of these, right? Which allow you handle all sorts of movements and interaction with the user. But we'll talk about some of the ones that are most relevant. So on change is going to be invoked when we click on the checkbox. And what we're doing is that we are calling set done with a negation of whatever the value was. So we're toggling. So if it's true, it becomes false. False becomes true. And we're using it to drive the rendering of this input field, this checkbox, with the property checked. Checked. If it's true, it's rendered with the checkbox. If it's false, it's rendered not checked. Okay, so we are controlling whether this checkbox is checked or not, right? And the value done is available to anybody who wants to use it. Here, it's being used to display either one text or another in this paragraph, either done or not done. So this toggles. And we're also doing it here to toggle the display of some other div, right? This message, this alert box, right? That displays either yay, you're done, or not, right? Hiding or showing it. Okay. So you could use this done in other places, and just with one checkbox, right? You are driving this value that is being used in multiple places in the screen. Make sense? Pretty cool. Again, this I forgot to put it here, but this would be also a use client component. right? This can only be rendered on the screen, right? You can't have the server hide something, show something. The server can't do that, right? It needs to be done on the client. The client can manipulate dynamically the DOM. The server can't. Here's another example using plain strings. Here's first name and set first name and initialize to John. And here we have the input field that, as you type, right, as you type each character, the on change is being invoked. This time around, we're pointing out that there's an event, right? When on change triggers and calls your callback function in here, it can pass you an alternative, right? An optional event object, right? Which we have been ignoring. Here too, it passes an event object, which we have ignored. Here too, it passes an event object, which we have ignored, right? This event object has all sorts of meta information, right? It has the timestamp, when the event occurred, where was the mouse exactly when you clicked on this, right? Whether you have the shift key or the control key pressed at the time that you did the click, right? So you can distinguish between click and shift click, right? It has a lot of metadata, right, about what was happening when the event occurred. Okay, but it also has the most important part is that it has a reference to the element that generated the event, right? In this case, the one who generated the event is the input field itself, right? The input is notifying us that, hey, I'm notifying you that somebody clicked it or somebody typed. There was a keystroke on the input field, right? So eTarget has a reference to the input field, yes, and dot value has the current value of the input field. So what we're doing here is that we are basically accumulating each character, for each character stroke, right? We are updating the first name value here for each character that's being added, right? We're updating and synchronizing what the input field says in our local state variable. Everybody good? Right, so we're initializing the state the input field to be first name, and then we are listening to the event handlers and updating our event. So now they're tied, right? Whatever the input field does, we have it, and whatever we have, the input field has. So they're tied together. Everybody good? So they're bound. Dates is it's a little bit more involved because it's an object, right, that has actually several values at the date, month, year, has hour, minute, second. So it has a lot of it has its own API. So we are initializing it to a new instance of date, which is the current date, right? That's today's date, and then it has all sorts of input fields to get the year, the month, the date. Okay, so here's just an example of converting this into a format of year, month, day, right, with dashes in between. And so we're declaring our input field of type date, initializing it with the value of the start date, formatted, making sure that it's if you remember input fields of type date, the value must be set with the format 4 digits for the year dash 2 digits for the month dash 2 digits for the day. Remember that when we looked at it a couple assignments ago? So this makes sure that it's formatted correctly. And then as we change the date, as we interact with the date picker, right? We grab the new date and reinstantiate the date object and reformat it to make sure that we can render it. Okay. And this is the example of the component. All right, so let's start doing something a little more interesting. Those were just primitive data types, individual variables, individual constants. But we can work with entire objects, right? And objects can be arbitrarily complex. Here is a very, very complex object of one string and one number, right? Peter and age, right? A number here. And now person now is assigned an object, right? That has two properties, name and age. And set person is going to allow us to update it, right? And the way we update it is by calculating a new version of the object. Right? So first here we are displaying the person in using Stringify. JSON Stringify is a utility function that allows you to render objects, right, as string representations, right? Notice that up to this point, whenever we're displaying something, we just say, done, right? Or first name. You see that? Right? It already knows how to convert itself into a string. Yes? Well, obviously a string knows how to convert itself into a string, but done or count or number, it already has a string representation, not objects. Objects you can't just say curly bracket person, close curly bracket, right? The React.js will complain saying, I don't know how to represent this object as a string. Okay, so you have to explicitly convert it into a string if you want to see it, right? So that's what JSON stringify does. It allows you to give an object, right, and it'll format it for you nicely, right, so you can display it. It's a great for debugging purposes, right? You can look at the object representation right there as you're coding. Okay, just to make sure that the object is correctly formatted and it has the correct values, it's not null, right, or something that you weren't expecting. So I encourage you to use it for debugging purposes. Great. So what we're doing here is that there are two properties, and we have two input fields, one for each property, right? One is displaying the name and the other one is displaying the age. Yes, makes sense, right? And we can modify each property individually with dedicated input fields, right? And the way we do that is by using onChange, right? We're going to be typing the name, the new name. We're going to be typing the new age of the person, okay? And so as we type, notice what we're doing. We're calling the mutator. See that? The mutator from both cases, right? We're calling the mutator. And what we're doing is that we're calculating a new object. So we are going to replace the old object with a brand new object, okay? And the new object is, notice it's copying the old object, okay? So we're copying the old first name or name, or we're copying the old age, but we are then overriding, right, either the name or the age in either case, yes, with a new value of name and a new value of age. See that? Right. So we can use the same mutator to manipulate any new property of the object, right? Oftentimes, folks what would do is that they would create individual functions to set the name separately and set the age separately. There's no need for that, right? You can just use the same mutator to do that. Okay, make sense? All right. Okay, so let's look at something more interesting, arrays, mutating or changing the state of an array. So here we have a simple array of just, the first 5 whole numbers, 1 through 5, right? So array, it's a very clever name, array, and have a mutator, right? That's going to allow us to change the array, right? So here we have, the array has the initial values of 5, and we can iterate over it really quick, right? UL array, and just iterate over it. Just make sure that the line item has key, so it has a unique value, and then we're just displaying item. Everybody good? Right. So this just displays 1, 2, 3, 4, 5. Next to it, we're putting a button, right, to delete the each one of them, and we'll see in a minute how we're going to do that. Okay. All right. Let's go back. All right. So we're gonna have buttons for each one of the items, so that we can remove the item. And we're going to have another button to be able to add additional items to the array, okay? So to add items, right, we're going to use the mutator to basically append at the end of the array. Notice that what we're going to do is that we're going to compute a new array to replace the old array, right? And the new array is going to be a copy of the old array. See that? Square brackets. So it's a brand new array. And the last element, we're going to randomly choose a number between 0 and 100. Okay, and so in a minute we'll see that we can click the button and call add element. Right, it's just going to randomly add numbers at the bottom. Right, and every time we click it, it's going to add again. Right, and it's going to re-render the whole thing, and we see the new items being added right after we click on the button. For deletion, also we're going to do the same thing. We're going to calculate a new array. And the new array is going to be a filtered. We're going to filter out from the old array. We're going to filter the item based on the index that we want to remove. So when we're going to click on these, we're going to pass the index of the item that we want to remove, and that index is going to be used for filtering out that particular item. Yes? All right, so basically we're computing a new array that has one less item. Yeah, make sense? right? And so that's how we're removing each item in the array. Make sense? All right, so here's where the implementation that we have here is that for adding elements, we're just going to call add element. Notice there's no arguments for add element. So there's no point, there's no need for parentheses, okay? Careful, no parentheses there. For deletion, we are going to call delete element, right? And so there's going to be, as many delete elements functions as there are items, yes? And it's going to call the index of the item that we are deleting, okay? Now, for this to work, there's going to be like 5, 6, 7 dozens of these delete item functions, right? So and each one needs to be able to remember, right? What was the index when that particular line item was added to the DOM? You see that? Because each line item is going to be a different DOM element in the node in the DOM, right? And so each one of these functions needs to be able to remember, oh, for item number 5, right? The index was whatever, okay? Well, 4 or something, yes. So for that to occur, that's where the closure comes in, right? The closure syntax here in JavaScript has the feature that whenever a new closure instance is created, right, it makes a copy of the state, right, when the closure was created. So that, and in that copy, it copies that the value of index was 2 or 5 or whatever it was, right, when you were iterating over this, okay? So that when the invocation actually happens, it can reconstruct the state, yes, and remember, oh, index was 5, so it'll call it with 5. Right? Make sense? Right? Again, that's because of one of the features of closures. Right? Okay. Now we want to start. Now that we can create states, right? We can work with forms, right? Presumably, I guess we could tackle any type of form now, right? We can create any arbitrarily complex form of different data types, different primitive data types, objects, dates, and arrays. What about sharing data now, right? And the question is, perhaps a form might be too complex to implement in a single page. Yes, it might be that a form might have payment information and billing information and right and shipping has a lot of information, credit card information, right, all in one page, and probably that's way too complex to have a single page. Probably you're going to split it out into multiple components. Yes, and each component, okay, is going to deal with each form, right, and probably all the validation that goes around for validating shipping information, right, validating billing information, right, okay, and shopping cart information on whether we actually have those element that many quantity that you're asking for. Make sense? So usually you're going to break it out into separate components. The component that does the deals with the shipping, billing, right, and all that. Each one in separate components. So now you're going to have, well, okay, where do I declare the use state? Where do I declare these objects, these arrays? But typically, you would declare it at the top level, right? At the our big page. Yes, you would have your big use state with a big object. Yes, but then separate components need access to that to that information. So you'll share it with the other child components plus all the setters. Right, you're gonna have to pass them around because the other child components are going to be updating the state. Yes, right. So the parent is going to maintain the state, but it's going to have to share the state with the children. So let's look at examples of this. Okay, here's a trivial one, a really easy one. Here we have before we had a counter. Yes. Well, let's split that counter into two components: a parent component and a child component. Yes, right. Now here's our child component. No, wait. No. Here's the parent component. Here's the parent component, and it's declaring a very complex state of a number, a counter. Okay, very complex state. But I'm trying to make the point. Okay, that of the challenges of doing this. So we have a counter, And here's our child component. Okay, and because this is a very complex object state, maybe one has all the shipping information, another one has all the billing, blah blah blah, all that. And so I want to pass around. I want to pass around to my child components the state. See that? That's what I'm doing here. I'm passing the child component the state, and I'm delegating to the child component the task of updating the state. Meaning the parent is not going to do this. The child is going to do the update. So it passes a reference to the setter. See that? Okay. And so in the child component, we receive a reference to the counter and a reference to the mutator, right? The setter function. See that? And we're declaring here that the counter must be a number and that the setter must be a function that takes an argument and returns void. And internally, I can do the same thing that I did earlier, right? Of two buttons that manipulate and set the state, right? So this is exactly as I said earlier. But notice that the child is not the one who's maintaining the state. See that? It is not the child who's maintaining the state. It is the parent. The parent is maintaining the state. I am modifying it on behalf of my parent. Yes? Right? Okay. Now, so now what happened is that we have split the work of one component into two components. Yes? Okay. And the way they work is by the parent sharing the state and sharing part of the responsibility by passing it references to the mutator. Make sense? Now, when it's two components like this, one or two, it's fine. It's trivial. It's not too hard, right? But imagine that this were not just two components, but it's so complex, right? With objects, and inside of those objects are arrays, and inside of those arrays are other objects. You might start splitting it up not only into two, but it says, oh well, each one of these are more than 100 lines of code, right? If I make if I commit this, somebody's going to push it back and say, no, it's too complex. You break it up into smaller components. So you might end up with not two, but three or four or five components that are deep, right? That are, you're applying best practices. You want to make sure that not everything is done in one. You need validation for this, validation for that. You need to go out to the server, make sure that you have that many products, right? That the dates are correct, right? That the shipping dates are correct, that the tax is correct. It can get fairly out of hand. So you might, you have a lot of these, one or two or three or four of these components all sharing data from the parent, passing it down to each one of the children. Yes, down to the leaves that are actually doing the work, and then the functions calling back, right, up to the parent who's maintaining the state, right? So all this data that's going back and coming back up, that starts to become very, very complex to work with, right? It starts dealing with tight coupling, right? All these components are now very tightly coupled, right, in a very orchestrated, right, dance, right, or of dependencies amongst each other, right? That if you remove any element in this chain, you break the whole thing, right? Because there is data passing through each one of them down to the children, and there is behavior going back up to the parent. Yes, right? And they're all tightly coupled in this chain of dependencies, right? And that is what oftentimes referred to as property drilling, right? That you're sending all these properties from the parent down to a child, down to a child, down to a child, where it's actually needed, right? And then the data has to come back up, right? Up, from the grandchild to the grandchild to the child up to the parent. Yes, and orchestrating all this communication can get very, very complex. Okay, that's why we start considering other options that we'll discuss a little later. Global state variables. All right, so let's do a little more challenging example. Right. Again, first we'll implement this using just plain old use state. Okay, and then we'll try to everything implemented in one single page, right, or one single component, and then we'll try to break it up into smaller components, right? And because I'll make an argument that this could easily grow into a fairly complex and sophisticated application, right? And then you'll have to start breaking it up, right? This could easily uh, become hundreds of lines of code, right? That best practice, you might want to break it up into 2, 3, 4, 5 pages or five different subcomponents. Yes, and now you're going to find yourself that you have to pass state variables back and forth and functions back and forth between these components. And say, okay, this is getting out of hand, right? And says, okay, and then somebody might say, well, I don't only need this data, this to do, not only here. I needed to render them here. I need to render them over there. I need to render them everywhere in the application. Oh no, what do we do? Okay, how do we share this data across multiple screens, right? And also I'll make the argument that breaking up all these components can lead into tight coupling, right, of sharing data across multiple components. Yes, and then the savior is going to be Redux. Okay, that's my spiel, right? Of what am I trying to convince you of why would you even consider Redux? Okay, let's start with something trivial. Okay, so here we have an array of objects that represent to-do items, right? I want to learn React, learn Node. Okay, and those are two objects, two to-dos, and we can render them easily, right? In a list group, we can do to-dos.map list group item, and we're displaying the to-do title, right? And we're using the to-do ID as the key. Make sense? Nothing new here, right? Now, right now the to-dos are static. We could not change them because it was just an array. So that we can manipulate the array, right? We want to be able to add to-dos, delete a to-do, update a to-do, right? So we're going to wrap the array with a use state from React, and just parentheses, boom, it's a state variable, right? Now we can manipulate, we can use the new set to-dos to compute a new array of to-dos, right? We can append to it, we can delete from it, we can manipulate individual objects, right? By using the set to-dos. Everybody good? Okay. So for instance, to be able to delete a to-do, I can have a function that, if you pass me the ID of the to-do, I can create a new array of to-dos that is just going to skip over the to-do for that particular ID. Yes? Right, if you give me the ID, I'll compute a new array of to-dos that's going to filter the old to-dos so that it doesn't have that particular to-do for that particular ID. Everybody good? Right? And then I just set to-dos. It changes the array with a missing to-do, and then the list of to-dos re-renders. Everybody good? Okay. So and to invoke them, I can just add a new delete button to the list group item, right? So that on click it calls delete to-do, and I pass in the ID of the to-do that I want to remove. Right? Notice that all this is local state. Yes? There's no dispatch, right? There's no store. Everything is local. Yes? Right? We're not sharing anything with anyone. It's only confined in my local component. Yes? Right? Nowhere outside of my component can anybody access my to-do array. Yes? Only within this one component. Yes? Everybody good? All right. All right, so let's do something else. Let's add a to-do. So I'll have a template of a to-do object with a dummy ID or dummy title, right? And in my new add to-do function, I'll create a new timestamp based on a date, and based on a timestamp, and I'll create a new to-do object with a new ID, with a unique ID, and a title, with a dummy title, learn Mongo or whatever. Okay, and the new to-dos will be a new array that has all the old arrays copied in front, and then we'll append the new to-do at the end. Everybody good? Yeah. And then I use set to-dos to update to-dos. Right? And I guess this should not be here. I'm getting ahead of myself. So now I can, I'm going to add a new add button that if I click on add, it's just going to add a new to do at the bottom. Obviously, always the same thing. Learn Mongo, learn Mongo, learn Mongo. It's always the same object, right? A different ID, but it's always the same title. Yes. If we want to have different titles, we'll need to make the to do itself editable, right? So that we can change the to do. We can give it an initial state of some dummy ID and a dummy title. But now, right next to the add button, we can have a new input field that can manipulate the title of the to-do, right? So that I can now change the title. So now when I click on add, it will add a new to-do, but with my own title, right? With a brand new title. Everybody good? Right? All right, awesome. What about selecting a to-do? Because I want to edit it. I want to edit that to-do. So what we're going to do is that we're going to add an edit button to each one of the to-dos. We're going to copy that particular to-do object to my editor up here so that I can now change the title. And I'm going to add a new button maybe like update or save or whatever, right? Which is going to then update my array with my new object, with my new title. Yes? Not with a new ID. We're going to keep the old ID is going to stay, right? I'm only going to change the title. So we'll do that with a new edit button right here that is just going to use my set to do here that I just added here with my use state. So what's going to do is it's going to copy that particular to do into my state variable, and then my input field will pick up the change and will change the title. So if I click on this one, this will say learn React. If I click on this one, it'll say learn Node. So if I click on one or the other, right, it will copy the title and the ID. Right, remember also the ID. It's copying the whole object, right, the title and the ID, of which here I'm displaying the title, and I can edit the title. Well, yeah, I can edit the title right here. I can edit the title of whatever the current to-do object is. I can change it. Okay. And finally, we'll add an update or a save button, right, which will call updates to do, which I don't have here. I don't have to do here. Update to do. Okay, I'll add it. I need an extra slide here that implements to do. But basically, what it does is that it computes a new array, okay, which is mostly the same. Right? So what's going to do is that it's going to iterate over the array, and for all the items that is not the ID that I'm editing, you're just going to copy the old items. You're just going to keep all the old. But when it gets to the ID of the item that has a new title, right, it's going to copy it from the to-do state variable, right, which has the new title, has the old ID. Right? So it's going to replace, right, the old to-do with the old title, the new object that has a new title. Make sense? Right, so now that I have the new array, we use the set to do to update the to do array, and it re-renders with that particular item modified with the title. Make sense? Right, but I'll provide the slide in a minute. Okay, so now this is all in good. This totally works. But now I'm going to make the case, right, that this could become fairly complex, right? I mean, this could grow to be Jira, right? I mean, what is Jira? Jira is a very sophisticated to-do list, all right, where you can have thousands of workers, thousands of issues, thousands of to-do things that you have to do, all the things that we have to do, right? Everything is in the backlog, and we assign it to users, to developers, at a particular intervals of sprints, 2-week sprints, 3-week sprints, whatever, right? And it's a bucket. So it's a subset of a to-do, a subset of a subset of a subset of a whole bunch of just huge to-do lists, right, from which we pick, and allows you to organize very, very complex to-do items, right? So a to-do item here, the to-do right now is trivial, just an ID and a title. But this could easily become a due date, right? How many points, right? Who is it assigned to? What sprint, right? What epic? So this could easily become fairly complex, right? And if I'm gonna have editors for the in these in this ad here, you wouldn't just have an input field for the title. You would have drop downs for date pickers for when it's due, right? Uh, you know, pickers for who is this assigned to? Yes, what epic, what sprint. So this editor right here could be fairly complex. Each one of these could be fairly complex. You might say, well, maybe I don't want to edit it here. Maybe I want to edit it in a separate page. It takes me to a different page where I can edit it, save it, and then come back. Right? So, oh, okay, well, now you're talking about 2 pages that need to talk to each other, right? And this is a list from which I've taken it from a bigger list, right? And so my point is this could easily become something far more sophisticated and ambitious, okay? So what are the types of complexities that you might run into when you start breaking it up into multiple components, multiple pages, right, that now have to coordinate amongst each other? Because when everything is in one component, in one page, it's trivial. You can get away with just use state. But when you start breaking it up into multiple components, multiple pages, then use state actually starts getting in the way. Okay? So I'm just going to give you just a taste of that. Right? So say you start breaking up things and say, well, instead of having and rendering the to-do items, right, right there in the to-do list, we're going to break it up into another component called to-do item, right? And the to-do item, the only thing that it does is that, so basically it's this code, right? It's the code of the list group item. So imagine I grab this code right here, and I'm putting it now in a separate component. I'm going to call that the to-do item. Now, if I do that, if I move this to a separate component, notice that I'm going to lose references to the function to-do, set to-do. I'm not going to have a reference to it anymore because it's going to live with my parent. I'm not going to have a reference to it, so my parent is going to have to pass it to me. Yes? I'm no longer going to have a reference to the to-do object, right? So my parent is going to have to pass it to me. The delete function that was here also, that needs to be passed to me. You see that? Okay? Because my new to-do item is not going to have any of that. So I copy this whole thing and I pass it, and I paste it in here. My to-do item. This is where it renders. To-do, it needs a reference to the delete to-do. It needs a reference to the set to-do. It needs a reference to the to-do. See that? So my to-do item needs to accept as argument a reference to the to-do, a reference to the delete to-do, the set to-do, right? And then obviously declare them as data types here. Everybody good? Right? So whenever I move it to a separate page, a different component, I need to maintain the dependencies, right? The parent needs to pass it to me, and I need to accept it over here. So we can keep working together. Yes? Right? My parent, right, needs to pass to me a reference to the to-do, a reference to the functions, and then now it works the same way. Now, obviously, this is a good design, a good practice, right? Because I replaced maybe 20, 30 lines of code with a single component. Yes? So the parent obviously, becomes far more simple to understand what it's doing. I'm iterating and I'm passing these things to the to-do item. So it's great. And again, if it's something as simple as this, as one parent and 2 children, maybe Redux is not the answer, right? But again, I want to make the argument that this could become far more complex. Okay, this could be rendering a board, and the board can be part of an epic, right? Could be part of, and then each user has their own boards, right? As they move their items from various states during the sprint. Yes. Okay. Let's do the same thing for the form at the top. The form at the top allowed us to have a button to add a new to do, right? A button to update the to do, and it has an input field where we can type, right, the title for the to do. Yes. And so here's the form with the two buttons, one for the add and the other one for the update, and then the input field, right, where we can type the title of the to-do. Yes? Again, because I moved it to a new component, to-do form, I don't have any of these. I don't have add to-do. I don't have update to-do, right? You're going to have to pass that to me. I don't have reference to set to-do. As a parent, you're going to have to pass that to me. So in my signature, I need to receive a reference to the to-do, a reference to set to-do, add to-do, update to-do, right? Now we, as a child and a parent, now we are dependent on each other. We're tightly coupled, just fine, right? It's not too difficult. So once I do that, I can rewrite my parent. And making sure that I maintain the dependencies. I pass down a reference to the to-do object and all the mutator functions: add to-do, update, set to-do. Everybody good? Right? And this works just the same way it used to work. And it's a good practice, right? To break up stuff into smaller units. Yes. Okay. But with the cost here is that we've created a strong dependency between two components, right? Which, if it's something as trivial as this, it's not too bad. It's okay. We could live with this. But again, if this becomes something more complex where actually I don't just have two components, these are 3 pages, right? And each page has a whole bunch of other components. But then we start thinking, well, maybe UState is not the solution. Maybe it's time to consider something more sophisticated.